Have you ever wondered if we could colonize Mars? Why would we want to do that, you might ask? Well, the reasons are as multifaceted as the red planet itself. Firstly, it's about exploration. Since the dawn of humanity, we've been explorers. Our ancestors crossed vast oceans and trekked through endless deserts, driven by an insatiable curiosity to discover what lies beyond the horizon. Mars, our neighboring planet, is the next frontier in this grand journey of exploration. It's a whole new world, waiting for us to unravel its mysteries. But it's not just about exploration, it's about survival. Earth, our only home, is under increasing strain from climate change, resource depletion, and population growth. The question isn't whether we could colonize Mars, but whether we can afford not to. Mars offers us a potential lifeboat, a second home in our solar system where humanity can continue to thrive should disaster strike on Earth. And then there's the scientific aspect. Mars is a tantalizing treasure trove of scientific knowledge. It's a planet with a history as old as Earth's, yet it's remained largely untouched. By studying Mars, we can learn about our own planet's past and future. We can look for signs of past or present life, answering one of the most profound questions in science. Are we alone in the universe? Finally, colonizing Mars is about pushing the boundaries of what's possible. It's about innovation, about creating new technologies and solutions that stretch our capacities as a species. The challenges of colonizing Mars will force us to innovate in ways we can't yet imagine, driving technological advancements that could benefit not just Mars colonists, but all of humanity. So the reasons for colonizing Mars are as vast as space itself, from scientific discovery to ensuring our survival. It's a bold vision, a grand challenge, and a journey that could define the future of humanity. Beyond the reasons, what could be the benefits of such an endeavor? Let's take a journey into the future. Imagine a world where we've successfully colonized Mars. The benefits could be immense. Firstly, technological advancements. The challenge of settling on Mars would push the boundaries of human innovation, leading to breakthroughs in engineering, robotics, and renewable energy. Think of the technological leaps we've made since the first moon landing. Mars could be our next giant leap. Secondly, economic growth. Space industries could become a new frontier for economic expansion, creating jobs and stimulating investment. The space sector is already worth over $300 billion, and Mars could multiply this figure. Finally, and perhaps most importantly, colonizing Mars would offer an unprecedented opportunity to learn more about our own planet. By studying Mars's geology and climate, we could gain invaluable insights into Earth's past and future. The benefits of colonizing Mars could extend far beyond the red planet, impacting our technology, economy, and understanding of Earth. What kind of technology would we need to make Mars our second home? Now, that's a question, isn't it? First things first, we need advanced spacecraft. These aren't your run-of-the-mill shuttles, but specialized vessels designed for the long haul. They must be equipped with life support systems, radiation shields, and the capability of carrying all the resources necessary for the journey. Next, we'd need systems to provide food, water, and oxygen on Mars. Hydroponics and aeroponics could be our answer for sustainable agriculture. For water, we might harness the ice on Martian poles, melting it, purifying it, and recycling it. Oxygen generation systems could convert the carbon dioxide in the Martian atmosphere into breathable air. And let's not forget the technology to protect us from the harsh Martian environment. Advanced suits, habitats with radiation protection, and temperature control systems. The technology required for Mars colonization is vast and complex, but not beyond our reach. Once we get there, where would we live? It's a question that sparks a flurry of imaginative, yet practical solutions. Housing on Mars would need to be much more than a roof over our heads. It would need to stand up to the planet's harsh environment, which includes extreme cold, thin atmosphere, and high radiation levels. Protection from these elements is paramount. Houses might need to be partially or fully underground to shield inhabitants from harmful radiation. They would be constructed from materials that can withstand temperature extremes, perhaps even utilizing Mars's own soil, known as regolith. Temperature control is another key consideration. Mars can swing from a day high of 20 degrees Celsius to a frigid -80 degrees at night. Thus, insulation and heating systems would be crucial. Finally, these Martian homes must be self-sustaining. Think greenhouses for food, systems for recycling water, and solar panels for energy. Housing on Mars would need to be robust and self-sustaining, a true testament to human ingenuity. But what is Mars really like right now? It's a question that resonates with every dreamer who's ever looked up at the night sky and envisioned a life beyond our own planet. Let's delve into the current conditions on Mars. To begin with, the atmosphere on Mars is incredibly thin, only about 1% as dense as Earth's. This lack of atmospheric pressure means that liquid water cannot exist on the surface for any significant period of time. It either quickly evaporates or freezes. However, the presence of ice at the poles and recent discoveries of subsurface liquid water give us hope for the potential of life and resources for future colonists. The thinness of the atmosphere also means that it does a poor job of retaining heat. The average temperature on the Martian surface hovers around a chilly -80 degrees Fahrenheit, with winter temperatures at the poles dropping to an even more bone-chilling -195 degrees. These extreme temperatures pose a significant challenge to human survival and the functionality of equipment. The dusty surface of Mars is another aspect to consider. Dust storms, sometimes enveloping the entire planet, are common. These storms can last for weeks, reducing sunlight and visibility, affecting solar-powered equipment, and potentially damaging structures and machinery with their abrasive nature. On top of all these, Mars has only about 38% of the gravity we're used to on Earth. While this might make for some fun basketball games, it also presents potential health problems over long durations, such as muscle and bone density loss. Despite these challenges, the allure of the red planet remains. Mars is a world of stark beauty, with its towering volcanoes, immense canyons, and mysterious dry riverbeds. It's a world waiting to be explored, understood, and perhaps one day called home. Mars is harsh and inhospitable, but not insurmountable. With the right technology, ingenuity, and determination, we may yet find ways to thrive on this distant frontier. After all, the human spirit is not easily deterred by adversity, but rather is often emboldened by it. So the big question remains, could we actually live on Mars? When we ponder the possibility of life on Mars, we're opening up a Pandora's box of challenges. Mars, with its harsh and unforgiving environment, presents a colossal task for human survival. However, the very essence of human nature is to explore, adapt, and overcome. The Martian atmosphere, composed mostly of carbon dioxide, is thin and lacks the oxygen necessary for human life. Yet, technology is advancing at a pace where we could potentially convert this carbon dioxide into breathable oxygen. Scientists are also exploring the idea of terraforming, altering the Martian environment to make it more Earth-like. Water, a critical resource for human survival, is scarce on Mars. However, recent discoveries of ice deposits beneath the Martian surface give us hope. With advanced technology, it could be possible to extract and purify this water for human consumption and cultivation. The gravity on Mars is just 1/3 of Earth's, which could pose long-term health risks for settlers. But again, technological advancements might hold the answer. Artificial gravity, though still in the realm of science fiction, could become a reality with enough research and development. Then there's the issue of radiation. Mars lacks a magnetic field like Earth's, which protects us from harmful solar radiation. Future Mars dwellers would need to develop technology to shield themselves from these damaging rays. And let's not forget Elon Musk's ambitious Mars colonization project. His company SpaceX is developing the Starship, a vehicle designed to carry humans to Mars in the not-too-distant future. The goal? To establish a self-sustaining colony on the red planet. Musk's vision of a Martian city teeming with life may seem far-fetched now, but who knows what the future holds. Living on Mars may sound like science fiction, but it could be a reality in our lifetime. Yes, there are many obstacles to overcome, but with our relentless spirit of exploration and innovation, we may soon call Mars our second home.